Hey there, and welcome to this explainer. Go ahead and pull up a chair. Look, whether you're a junior developer just getting started, or honestly, anyone looking to step up their game and really grasp the future of software architecture, you are absolutely in the right place. Today, I'm putting on my mentor hat because we're going to completely demystify AI agents. We hear the term everywhere, right? But today, we're actually going to look under the hood at the real, practical architectural blueprints that make these things tick.
Okay, so here's our game plan for today. We're going to start with the evolution of autonomy, then move right into the 4 core design patterns and dissect the anatomy of a single agent. From there, we'll scale things up, looking at coordinating multi-agent systems and parallel versus asynchronous processing, before finishing with what I think is the most exciting part, the massive AI agent opportunity. All right, let's dive into this.
Section 1. The evolution of autonomy.
So before we can go off and build the complex systems of tomorrow, we really need to understand exactly how our workflows, and honestly, our entire relationship with AI, are shifting right now. It's all about how much independence we're actually handing over to the machine. Think about how you probably use AI today. That's step 1, non-agentic. You write a prompt, something like, write me an essay, and the AI gives you a response from start to finish in just one straight shot. It's coherent, sure, but often a bit vague. Now, step 2 is the agentic workflow. This is a game changer because it's no longer a straight line, it's a circular, iterative process. You ask it to create an outline, think about what research is needed, write a draft, and then revise it. It's this continuous loop of thinking, doing, and revising. And finally, we have step 3, fully autonomous. This is the holy grail. This is where the AI completely independently figures out the exact steps, tools, and revisions needed without you holding its hand at all. We aren't 100% there yet, but for sure, that is the blueprint we're building toward.
Moving right along to Section 2. 4 core design patterns.
If you're going to architect agentic workflows, you absolutely need to understand the fundamental building blocks established by the industry leaders. Now, I love a good memory trick, and here's one that'll definitely stick with you. Red turtles paint murals. Pretty catchy, right? This stands for reflection, tool use, planning, and multi-agents. These are the 4 foundational agentic design patterns. Honestly, whenever you're architecting a new system and you feel stuck, just come back to this simple phrase. Are you using reflection? Do you have the right tools? Is there a planning stage? Do you need multiple agents? Let's break these down a bit more.
First up is reflection. This is simply asking an AI to carefully review its own output. Imagine you ask an AI to write some code to complete a specific task. In a standard non-agentic workflow, you just take whatever it spits out. But with reflection, you prompt the AI to check its own code for correctness, style, and efficiency. The AI actually looks over its work, maybe realizes, oh wait, I made a mistake on line 5, fixes it, and improves the output entirely on its own. So the really crucial point here is that reflection turns a single prompt into an active, self-correcting loop.
Next, we have tool use and planning. And man, this brilliantly illustrates how we bridge the gap between just generating text and actually taking real-world action. Tool use means giving your AI access to external resources, like, say, a web search to compile product reviews, a code execution tool to calculate 7% compound interest over 12 years, or even access to your calendar. When you combine this capability with planning, the AI can map out highly complex tasks. For example, if you ask it to generate an image of a girl reading a book in the exact same pose as a boy in a reference photo, the AI actually plans out the steps. Analyze the pose, generate the new image, and maybe even use text-to-speech to describe it. It's reasoning through the steps and grabbing the right tools to execute them. It's wild.
All right, Section 3, anatomy of a single agent. Before we can build a massive, coordinated team of agents, we have to perfect the individual unit, right? So here is your second memory trick for the day. Tired alpacas make tea. This breaks down the 4 essential components every single agent needs to function: task, answer, model, and tools. Let's say we're building a travel planner agent. The task is to plan a 3-day trip to Tokyo on a budget. The answer you want back is a detailed itinerary with cost breakdowns and hotel bookings. The model is the specific large language model you choose under the hood, like Claude or GPT. And the tools are what it needs to access to get the job done, like Google Maps, Skyscanner, and Booking.com. It's a simple checklist, but if your agent is failing, check your tired alpacas, because I guarantee one of these 4 components is either missing or poorly defined.
Section 4. Coordinating multi-agent systems.
So we're now moving from a single contributor to a full-blown organizational structure. Think about it. Why have one AI try to do everything when you can have a team of highly specialized experts? When we link these agents together, we generally look at 2 primary patterns. The first is the sequential pattern. Think of this exactly like a classic assembly line. One agent extracts text from a scanned document, it passes it to a second agent who summarizes it, a third extracts the action items, and a fourth saves it all to a database. It's clean, it's linear, it just works. But sometimes, tasks are messier, and you need the hierarchical pattern. This is where you have a top-level manager delegating to sub-agents. Imagine writing a complex business report. The manager agent receives the task and then delegates to sub-agent 1 to monitor market trends, sub-agent 2 to check internal customer sentiment, and sub-agent 3 to track company metrics. They all do their jobs and report back to the manager, who then aggregates those insights to make a final business decision.
Section 5. Parallel versus asynchronous processing. As our applications get larger and way more dynamic, those sequential and hierarchical structures sometimes just aren't fast or reactive enough. So let's compare two more advanced approaches. Parallel processing is pretty much exactly what it sounds like, and it's fantastic for massive data analysis. You take a huge chunk of data, split it up, and have multiple agents process their respective chunks simultaneously to speed things up, before merging it all back together at the end. Asynchronous processing, on the other hand, is when agents execute tasks completely independently and at totally different times. This is perfect for real-time, highly uncertain conditions. Think about an AI-powered cybersecurity threat detection system. You've got one agent constantly monitoring network traffic, another looking for suspicious user login patterns, and a third just doing random sampling. They act entirely independently, and if anyone finds an anomaly, boom, they flag it instantly. But as you can imagine, this brings up an undeniable challenge.
And that challenge is managing chaos. As a developer, you really need to internalize that. As you increase the complexity of these multi-agent systems, you're basically increasing the amount of chaos within them. Because you no longer have direct, step-by-step control over what every single agent is doing at every second, having all these moving parts interacting creates unpredictability. It actually mirrors a growing human company perfectly. A startup with 2 people? Super easy to manage. A corporation with 1,000 people? That requires intense focus on hierarchy, continuous feedback loops, and incredibly strict organizational structures. When you build large multi-agent systems, you aren't just coding anymore. You are literally designing a digital organization.
Finally, Section 6, the AI agent opportunity.
Now that you understand the architectural blueprints, from those self-correcting reflection loops to complex hierarchical coordination, let's talk about why this actually matters for your career and the broader market. This is a massive takeaway derived from some incredible advice out of Y Combinator. For every SaaS, or software as a service company, there will be a corresponding AI agent company. Just pause and think about all the traditional SaaS unicorns we rely on today. Adobe, Salesforce, Shopify, Canva. Literally every single company that operates as a traditional software service is ripe for a vertical AI equivalent. Traditional SaaS gives humans the tools to do the work. AI agent architectures actually do the work for the human. This is literal gold for anyone looking to build a business or guide their company's tech strategy into the future.
So, I'm going to leave you with this final, provocative thought. You now know the 4 core design patterns. You know how to structure a single agent, and you know how to coordinate a multi-agent team. So take a look around the software landscape today. Which traditional SaaS unicorn are you going to replace with an AI agent architecture? The blueprints are right in front of you. Now it's time for you to go build. Thanks so much for joining me for this explainer, and keep learning.